A company is building a Gen AI customer support service using Amazon Bedrock. The application needs to retain conversational history for personalization and process ambiguous queries through clarification workflows. The system must support thousands of concurrent users with minimal latency and maintain encrypted records of all user interactions. Which architectural design fulfills these requirements?
Option A. Implement an AWS Step Functions Express workflow for orchestration. Use AWS Lambda for clarification logic and store session history in an Amazon RDS database with session IDs. Option B. Use an AWS Step Functions standard workflow to manage clarification steps, utilizing the wait for a callback pattern. Store conversation data in Amazon DynamoDB with server-side encryption enabled.
Option C. Use an Amazon API Gateway REST API with AWS Lambda to manage context. Save every interaction as a unique JSON object in Amazon S3 with server-side encryption. Option D. Use AWS Lambda functions to invoke Amazon Bedrock. Manage clarification logic using Amazon SQS queues, and store conversational history in an encrypted Amazon Elasticache Redis cluster.
This scenario explores architectural patterns for high-scale AI applications. Key considerations include state management for conversational history, the ability to orchestrate complex branching logic like clarification loops, and the need for high concurrency, low latency data storage solutions that provide built-in security features for sensitive user interactions.
In my view, the correct answer is option B. This approach excels because it leverages AWS Step Functions Standard to orchestrate multi-step workflows, which is perfect for complex tasks like human-in-the-loop clarification. By using the wait for a callback pattern, the system can pause effectively until it receives the necessary user input to resolve ambiguity. Pairing this with Amazon DynamoDB provides the high concurrency and low latency performance required to manage conversational state at scale, with encryption built right in.
Let's look at why the other options are less ideal. Option A suggests using Amazon RDS, which typically isn't as efficient as DynamoDB for high concurrency, unstructured session data. Option C relies on Amazon S3, which introduces too much latency due to the overhead of object storage operations for every individual turn. Finally, Option D proposes using SQS for orchestration. This is an anti-pattern, as SQS is a queuing service, not an orchestrator, and Redis is primarily for caching, not for persistent long-term history. As a tip for your exam, always look for the best tool for the specific job. Recognize that step functions are intended for orchestration and state management, whereas SQS is for decoupling components. Similarly, understand the difference between persistent storage for session history, like DynamoDB, versus transient caching or high-latency object storage, which are better suited for different use cases.